welcome back. Today we are going to talk about domain and range of discrete graphs and discrete coordinate points, or you can even do this from a table as well. So first off, we're going to look at some coordinate points. First thing we want to do, kind of a throwback to last concept, we want to determine if something's a function or not. So I've already pre-drawn our mapping grids, and you guys can do this too. So once again, all of the x values are going to go into one circle together. All of the y values are going to go into one circle together. And then we can kind of map what x goes to what y goes. So for our first coordinate point, our positive 1 goes to negative 2. So I'm going to draw a line from positive 1 to negative 2. Our second coordinate point, negative 2, maps to 0. And then negative 1 maps to 2, and then positive 1 maps to 3. And this is where we run into an issue because negative 1 maps to two different things, which means for one input, that gave us two different outputs, which means this guy is not a function. That is not what we want to see for our functions. All right, just a quick reminder on our definitions of domain and range. Domain is the set of all input values, or the set of all x values, and our range is the set of all y values. So if we are given a list of coordinate points, all we know is that our domain is the x values. As far as we know, there are no points in between those guys. So for our domain, we are just going to list out all of those x values. So in this case, x equals 1. We have a negative 2, a negative 1, and then back to positive 1. We do not have to list the same number multiple times, which is really, really nice. However, the only thing that makes our domain look a little bit better, because we always look at domain from the smallest number to our largest number, is if we rewrote this in order. So let's go ahead and rewrite this in increasing order. So the smallest x value that we're given is negative 2. The next smallest is negative 1, and then our highest is positive 1. So we're going to list our domain and range in increasing order. All right, our range is going to be the set of all y values, or the set of all outputs. So if we take a look at our coordinate points, our outputs are negative 2, 0, positive 2, and positive 3. And so we want to write those y values in increasing order to represent our range. So we have negative 2, 0, positive 2, and positive 3. And that is how we can find our domain and range given a list of coordinate points. All right, let's do that one more time. So once again, we want to determine if something's a function or not. And this is kind of a throwback to the previous concept. Domain and range always kind of goes along with determining if something's a function. So if we go through our coordinate point, 1 maps to 1, 2 maps to 2, 3 maps to 5, 4 maps to 10, and 5 maps to 15. So since we had one input to one output, we do have a function. So yes, this guy does represent a function for us, since there is one output for every given input. All right, so domain, once again, is all of our x values that make up our function. So we want to write this in increasing order. So we have x equals, our first input is 1, then we have 2, 3, 4, and 5. So when we're just given coordinate points, we're going to list out all of the x values, and that represents all of the inputs. All right, our range is all of the outputs, or all of the y values of our coordinate points. So we have y equals 1 from the first coordinate point, 2, 5, 10, and 15. So sometimes coordinate points are really, really nice to list out domain and range because we're really just focused on the x values and the y values. All right, now let's take a look at discrete graphs. So these are very, very similar to what we just looked at. However, instead of the points being listed, the points are actually plotted on a coordinate grid. So in this case, for our domain, we are looking at all of the x values for every coordinate point. So x equals our lowest x coordinate point, looks like it is at -2 right here. Our second lowest is at -1. Then we go to +1 and then +3. So those are all of the x values of the coordinate points plotted. All right, now to find the range values, these are going to be all of the y values. So the lowest y value that I see is -2, and there's actually 2 coordinate points here that is at -2. The next lowest is right here, and that's when y equals 0. And then we have 2 points when y equals 1. And finally, our highest point up is when y equals 3. So this is our domain and range. If we want to determine if it's a function or not, remember we can always use that vertical line test, but we have actually 2 issues with this graph where for our inputs of 1 and 3, we have 2 different outputs. So this guy is not a function. All right, for our last one, looking at our domain, once again, we're looking at our x values in increasing order. So our lowest x value is at -2, and then we do have this coordinate point kind of hidden, which is when x equals 0. And then finally we have x equals 2 and x equals 3. All right, for our range value, we're looking at all of the y's. And we don't use any inequalities because we don't actually have a line connecting any of these points. We just have the points separately. So we're not really caring about any of those decimal points in between our coordinate points since they are discrete. They are very separate from one another and they're not connected. So our lowest y value happens right down here when y is -2. And then we go to when y is -1. Up at +1 right here, and then finally up at +3 with this coordinate point. So just be careful with your domain and range when you're calculating the different y values or the different x values. And for this guy to determine if it's a function or not, once again, we can use our vertical line test, and we don't have any issues with there being 2 outputs for every input or for a single input. So yes, this guy does represent a function. And that is how you guys find domain and range of discrete graphs with separate coordinate points or a given list of coordinate points.